Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. M and N are positive non-zero integers such that 100 less than 2 to the power m plus 3 to the power n less than 1000. And we are given two quantities. A quantity A is the maximum value of m plus n, and quantity B is 2 times the minimum value of m plus n. And we are given four options describing the relationship between the two quantities, and you have to pick the correct choice. So this is a very common quantitative comparison type question which is asked in standardized tests like GRE. So we proceed to solve this problem by first considering what could be the maximum values of m and n individually. We are not yet considering the maximum value of m plus n as a whole, but individually, what could be their max values? We start out by noting that when considering the higher exponents of 2 to the power 9 is 512, but the very next exponent, the very next power of 2, which is 2 to the power 10, and we're only considering here integral powers or integer exponents. So 2 to the power 10 is 1024, which crosses 1000. So that tells me that the maximum possible value that m can take is 9, because if m is 10, then 2 to the power m itself exceeds 1000, right? So the inequality won't be satisfied. So the maximum possible value that m can take is 9. And similarly, we can find the higher exponents of 3, basically, the exponent values for which 3 to the power n will cross 1000. And 3 to the power 6 turns out to be 729, and an easy way of figuring that out is if you note what 3 to the power 4 is, which is 81, then 3 to the power 6 will be 3 to the power 4 multiplied by 3 square, which is 9. So it will be 81 multiplied by 9, and that comes to 729. And then 3 to the power 7 will be simply 729 multiplied by 3. And I don't need to calculate the result, but it's pretty evident that this will be greater than 1000. So the maximum possible value of n individually will be 6, because if n is 7, then 3 to the power n by itself will exceed 1000, and so the inequality that's given will not be satisfied. So far we have considered the maximum values of m and n individually. We haven't looked at m plus n yet. But what happens if we set m to its maximum possible value, 9, and we do the same for n simultaneously? So we set it to its maximum possible value. In that case, 2 to the power m plus 3 to the power n becomes this: 2 to the power 9 plus 3 to the power 6, which is 512 plus 729. And again, I don't need to know what this sum is, but it's pretty evident that it's greater than 1000, right? So for these values of m and n, for m equal to 9 and n equal to 6, this inequality is not satisfied because 2 to the power m plus 3 to the power n exceeds 1000. So the maximum possible value of m plus n has to be less than 15, right? Because when m plus n is equal to 15, that's for the max possible values of m and n individually, which are 9 and 6 respectively, then the inequality 2 to the power m plus 3 to the power n less than 1000 is not satisfied. So we know that the maximum value of m plus n can't be 15. It has to be less than 15. So what happens if I decrement n by 1, meaning that I still keep m at its maximum possible value, which is 9. So I have 2 to the power 9, but for n, I reduce it by just 1 from its maximum possible value. And in that case, the inequality becomes 2 to the power 9 plus 3 to the power 5, which is 512 plus 243, and that comes to 755, which is less than 1000. So in that case, the inequality is actually satisfied. So we saw that m plus n has to be less than 15. But if m plus n is equal to 14, which is in this case, when m is equal to 9 and n equal to 5, the inequality, especially the upper limit of inequality, is still satisfied, right? So for m plus n equal to 14, we have, that seems like a permissible value. Now, we know that maximum value of m plus n has to be less than 15. At the same time, m and n being integers, m plus n should be also an integer, and the very next value that comes, that's less than 15, the very next integer value less than 15 is 14. And for that, we have the inequality satisfied. So we can conclude from this that the maximum possible value of m plus n will be 9 plus 5, which is 14. So next, consider what happens when we start looking for minimum values of m plus n. For that, we basically set m to its minimum possible value, which is 1. And we ask the question, well, if I set m to the minimum possible value, what is the least value that n can take, right? So the inequality has still got to be satisfied. And now we are more concerned about the lower limit of the inequality, because we are reducing, both m and n and trying to see what's the minimum possible. So we've already reduced m to the minimum possible value, because m is a non-zero positive integer and the minimum possible value it can take is 1. So if I do that, what's the least value of n for which the inequality will still be satisfied? So we have basically, if I set m is equal to 1, we get 100 less than 2 plus 3 to the power n. And from this we can write 3 to the power n is greater than 98. And we know that 3 to the power 4 is 81, so that's less than 98. But the very next integer power or integer exponent of 3 is 3 to the power 5, which is 243, and that's greater than 98. So in this case, it appears that for the lowest possible value that m can take, which is 1, the least value that n can take and still satisfy the inequality is n equal to 5. And in that case, m plus n adds up to be 6. Now, we haven't proven out that this is the lowest possible value of m plus n. But we know that the minimum value of m plus n has to be at most 6. It could be lower than 6, and we haven't proven that out. But it could be at the most 6, right? Because for m plus n equal to 6, the inequality is still valid with m equal to 1 and n equal to 5. So what happens if I double 6? Well, if I double 6 2 times the value, that becomes 12. And that is less than the maximum value of m plus n, which we showed earlier was equal to 14. So even if we take m plus n to the minimum possible value of m plus n as 6, and we double that, that still comes to be lesser than the maximum value of m plus n, which was 14. Now we haven't proven out that 6 is indeed the minimum possible value of m plus n. Well, the minimum possible value of m plus n may be lower than 6, and we haven't proven that, right? But even if we just take 6, which is kind of the higher end of our estimate of the minimum value of m plus n, then also 2 times that value fails to exceed the maximum value of m plus n. So from this, we can conclude that the maximum value of m plus n should exceed 2 times the minimum value of m plus n. So the correct choice would be option A. Quantity A is greater.